Hello everyone, welcome to my YouTube channel, and today we'll be discussing Palindrome Partitioning 3, which is again one of the most hardest problems of Leetcode and one of the mostly asked in interviews. So I would ask all of you to please pause the video and read the question for once. Okay, I hope you must have read the question. For all those who have not understood the question, let me explain them for once. So you have to divide the string into k parts such that each part is having at least one character, and you can also change some of the characters to make them palindrome. So what you have to do is you have to divide such that each of the substring is palindrome, and if it is not, you can change some of the characters. So you need to return the minimal number of characters that you need to change to divide the string. Suppose I take this, let's take this. So A, B, C, and the substance that you need is 2. So you need to divide this into two parts. So I can make a break here and here as well. So when I make a break here, it divides the string into A and B. This is a palindrome, but this is not. So if I change C to B or B to C, in any case, the number of modifications is 1. I can make a break actually here also instead of this. So in that case, the substance would be A, B and C. So this is a palindrome, but this is not. So I can change the character, and the number of modifications is again 1. Okay, let's take one more example. A, B, B, C, and K is equal to 3. So the number of substance that you require is 3. So I can break it here. I can break it here because I need to divide this into 3 substrings. Okay, so the substring which I'll get is A, B, and B, C. This is a palindrome. Cool. But this is not. So the number of modifications I need is 1. This is obviously not a palindrome. Number of modifications required 1. So the number of modifications in this partitioning is 2. But I can break it the other way around also. I can make a break here and here. So the substance would be AA, BB, and C. This is a palindrome. This is also a palindrome. This is also a palindrome. So the number of modifications is 0. So you have to make breaks such that the minimal number of characters need modification. So I hope you have got the question now. So let's see how will we do it. Okay. So how will we approach this? In any case, let's see that suppose I have a string. I have a string A, B, C. I have a string and I need to divide this into k parts. Okay, how will by normal recursion, like I can make a break here or anywhere, and I can pass the rest of the string. If I see rest of the string, in that rest of the string, I need to do the same thing. Na? Can have a string S, and the number of substrings required would be k minus 1. So I can actually do it by recursion now, right? I can do it by recursion. So if I see ABC or AABBC, and k equal to 3, sorry, 3, I can make breaks anywhere. I can choose my first break here or here also or here also or here also or here also. So it would be my leftover string would be A, B, B, C, and K would be 2. My leftover string could, if I make a break here, my leftover string would be B, B, C, and 2. If I make a break here, my leftover string would be BC, comma 2. If I make a break here, it would be C, comma 2. If I make a break here, it would be empty substring, comma 2. Actually, this case is not possible. So we'll return not possible. But all these cases are possible. So as you can see, in every step, suppose the length of the string is n. So there would be n minus k next recursive calls, and again there will be n minus k for each and every substring, or for each and every call. So it would be very, very complex. It would be very, very complex. So how can we optimize this? How can we optimize this? uh, Look at it closely. Suppose like this was the string, and my recursion is actually considering all the possibilities. So suppose I make a break here. Oh, sorry. So my leftover string would be B, B, C, and K would be 2. Suppose I make a break here now. So my leftover string would be 2, sorry, 1. Now I can make a break here actually also. So my leftover string would be A, B, B, C, and 2. Now I can also again make a break here or here also. So it would give me BC, comma 1. If you see this and this, these both are repeating. So why not to store the answer? If I already have calculated this thing, uh, I need not to again calculate BC, comma 1. So this way I actually see that I can use DP in this. Uh, I can use actually 3D DP, where I would have start, I would have a end, and I would have a k. K will tell how many substrings actually do I need, or how many modifications. So each and every entry of my DP array would give me the number of modifications I made from starting index to ending index by dividing this into k parts, the minimum number of modifications, right? So let's move to the code. Yeah, let's understand the code. So this is my function which takes a string s and k. This I have initialized my DP array. This is a 3D DP array. This is the initialization. Now I am sending all of this to a helper function which will take my string, which will take the number of parts I need to divide, which will take a starting index, which will take a ending index, and my DP array. Now, so suppose my end is lesser than start, which means actually the string has been completed. So now if I have to divide this into 0 parts, it means that string has already been divided, which means I need not to make any modifications. So I can return 0. Otherwise, if k is greater than 0, so suppose the length of the string is 0 and I ask you to divide this into suppose 4 parts, it's actually not possible, right? So I return any big integer. You can return int max, int min, anything. So this is what I've done. Okay. Now next part. If suppose my string is having length 4 and I ask you to divide this into 4 substrings. So what would be the answer? It would divide the string into 4 substrings of length 1 only, right? And each string of length 1 is always a palindrome. So this is my second base case. If my length is equal to k, I need not to make any modification, so I return 0. If the length of string is lesser than, suppose the length is 4 and I ask you to divide this into 7 parts, it is not possible, right? It is not possible. So again, I did the same thing. I return any big integer. Now suppose the length is 4 and I ask you to divide this into 1 part. So one part is actually the complete string, right? So one part is actually complete string. So the only thing which I could do is check how many modifications I need to make in this string, and that would be my answer, right? So this is what I have done. If k is equal to 1, I am basically made a check function which will return me how many modifications do I need to make in the string to make this a palindrome. Then I have stored the answer and returned. Now, the use of DP. If I've actually calculated the answer previously, this is what I'm checking. So actually have to return that answer. Na? Why to calculate this again? So this is what I have done. My -1 indicates that I have not worked for this case. So if this is actually not -1, I return the answer. Now, if I have not worked, I've started doing my work. This is my work. What I'm doing is I am basically considering each and every case. Suppose this is my string. I am considering this string also, this string also, this string also, this string also, each string, and passing the rest left over to my recursion, that it would return me how many modifications do I need to make in k-1 and the remaining substring. And I am considering this as my one string, substring, or one part, and I find how many modifications do I need to make in this part to make it a palindrome. So this is what I have done. I have made a call, one call, in which I'm dividing it into one part. My start is actually start. My end is actually I only, because I have started my pointer from here and it will go up till end. And I made a second call which actually works on the remainder part. So if I am taken one string, the leftover strings number of strings would be k-1, and this is the starting of the leftover string, this is the end, and this is my DPR. My answer would be number of modifications in this plus the number of modifications in this. So this is what I have done, and I've taken the minimum because I need to find the minimum number, right? So I've taken the minimum, then I've stored my answer, and I've returned my answer. So let me explain you my check function, which returns me how many modifications do I need to do. So suppose the length is actually 0, then in that case actually 0 modifications are required. So this is what I'm doing. I am returning any big integer in case end is lesser than start, because that case is actually not possible. Now what I have to do is I have to in a palindrome the length is actually this side also. Either if it's an odd palindrome, length of this is equal, or if it's an even palindrome, these both sides are equal. So this is what I'm doing. I have a start, I have an end. So each of this should match. So if they're not matching, then I need to modify one of the characters. In that case, answer is I'm increasing my answer and increasing my start and decreasing my end by 1, and I am finally returning my answer. So I hope you have got this question. I'll paste the link of this code in the description if you need any help. If you have any questions, ask them in the comment section. I would be happy to answer them. Uh, if you like the video, do hit the like button and please subscribe my channel. Thank you.